Okay, section 2.1 is rational numbers on the number line. So let's take a look here. We've got several types of numbers that we can talk about, and this really should say types of real numbers. We'll talk about that in a minute, but types of real numbers. So the first thing we have is natural numbers, or the counting numbers. In other words, the numbers that we use when we count items, 1, 2, 3, 4, etc. Then we've got the whole numbers. This is the natural numbers, and it adds 0 to the list. We don't use 0 when we're counting, but we do use 0 as one of our whole numbers. So 0, 1, 2, 3, 4, 5, 6, etc., etc. The next thing we add are the opposites of the whole numbers. So integers are all of these plus their opposites. So everything negative all the way up to -3, -2, -1, 0, 1, 2, 3, etc., etc. And the last category that we're going to talk about is rational numbers. Now, all of these are rational, but they are not all, let me start again. All of these are rational numbers, but they are not the only rational numbers. Rational numbers are any number, including whole numbers, natural numbers, and integers. Any number that can be written as a ratio or a repeating or terminating decimal. So a ratio, something like 2/3, something like 7/16, a ratio like 12/5, but also a ratio like 3/1, which is an integer, happens to also be a counting number. We can also do it as decimals, repeating decimals, or terminating. So 2/3 would be 0.66 repeating. That's a rational number because that decimal can be changed to a fraction. Or something like 0.75, which can also be written as 75/100ths or 3/4. So anything that can be turned into a ratio. Everything else is called irrational numbers, and we'll get into those later. So let's look at a Venn diagram. So all the real numbers, I just alluded to the fact that there are two big categories. One is rational, that's what we're going to be talking about today, and the other is irrational. Now there are also another whole category of numbers called imaginary numbers, but we're not going to get into those yet. So the real numbers are rational or irrational. In the rational number set, we have some subcategories. There are all the rational values, everything that can be written as a ratio. Inside that are our integers. Inside the integers are the whole numbers. And the smallest subcategory inside whole numbers are the natural numbers. So some numbers can be in more than one category. So let's look at a few. Where would I place the number 2/3? Well, it is rational. It can be written as a fraction, but it's not an integer or a whole number or a natural number, so it has to be here. What about the number 6? Well, it is a counting number, so it goes right in the middle. You can see that it is also included in the subset of whole numbers, also included in integers, and also part of the rational numbers. So the natural numbers are all of these categories. -12, it's not a natural number, it's not a whole number, it is an integer, which also puts it in the rational numbers. So we'll talk a little bit more about that together. All right, so graphing numbers on a number line. A coordinate is the number that corresponds to a point on a number line. So if I have a point plotted on a number line and asked you what is the coordinate of point A, you would say the coordinate is 3. So let's plot a few points. Plot the following numbers on the number line. Well, I see that my smallest number is -6.5, so I'm going to make sure I get at least to -7. And my largest number looks like a little bit more than 4. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. 1, 2, 3, 4, 5. So if I plot at least that many coordinates, I should be able to plot all of the values that I have listed over here. So 2, right there. 2/3, almost 1. Closer to 1 than to 0, 2/3. 4.3, a little bit past 4, not quite to 4.5. Negative 2.4, again, bigger than negative 2 in the left-hand direction, smaller than negative 2 to the left. So negative 2.4, go right about here. Square root of 14. So how am I going to approximate that? Well, I know that it's less than the square root of 16, and I know that it's greater than the square root of 9. That's 3, and that's 4. So the square root of 14 is between 3 and 4. I'm going to put it a little closer to 4 because 14 is closer to 16 than it is to 9. So between 3 and 4, closer to 4, that's going to be the square root of 14. And the last one is negative 6.5, all the way down here. All right, so plotting points on a number line. The other thing we're going to talk about with our number line is absolute value. The absolute value of any number n is its distance from 0 on a number line, and it's written as absolute value of n. These are the absolute value bars. When I'm doing order of operations, they act like a parentheses. So if there's anything inside the absolute value, I'm going to do it first, then apply the absolute value symbol. So if I want to plot the absolute value of 4, that means I'm looking for how far is 4 from the origin. So I shouldn't say plot, if I want to evaluate. Sorry about that. So if I want to evaluate the absolute value of 4, I'm looking for the distance. It is 4 units from the origin, so the absolute value of 4 is 4. How far is it from the origin? What about the absolute value of negative 4? Well, negative 4 is over here, but again, what is the distance? The distance is also 4 units. So absolute value talks about distance. So what if I wanted to find the absolute value of negative 6 plus 2? Remember I said this acts like a parenthesis, so I've got to do what's inside the parentheses first. So negative 6 plus 2 is negative 4. Then what is the absolute value of negative 4? We already said it's 4 units from the origin, so the answer to this is 4. Let's try a couple more of these. I'm going to put these up and let you try them on your own and then come back to the video. Okay, if x equals 8, I'm going to substitute 8 into my expression. Work inside the absolute value first. So that's the absolute value of 13. Now, what is the absolute value of 13? Well, 13 is 13 units from the origin. So my final answer is 28. What about if x is negative 10? So the absolute value of negative 10 plus 6, again, working inside my quote-unquote parentheses. So 15 plus the absolute value of negative 4. I haven't worked with the absolute value yet. I'm just working inside, so the absolute value stays. Now I'm going to apply the absolute value symbol. What is the absolute value of negative 4? We already said that negative 4 is 4 units from the origin. So my answer here is 19. And that's it for the video. We'll do some more work in class.